All right, hello everybody. It's Mike here. This is day 20 of math class, and that's of 40. So we are halfway done. So that's maybe scary to some of you, and maybe less scary to others. But we are halfway there. It's Tuesday, October 20th. This is the 10-question quiz solutions video. And this is the most recent one that we will use for a while here, probably the next 10 days. So let's get into things. Things have been getting a little bit more challenging over time, and these last few questions and this new set of questions is adding to your previous knowledge. So there's a little bit more complexity, but I'm sure everybody can handle it. So question one. We've got negative numbers here and positive numbers. Negative 6 plus 7 minus 8 plus 9. So what do we do with something like this? Well, you can always conceptualize a number line, and you can say that this is 0, and that this is like, I don't know, 10, and this is minus 10. That's how negative numbers works, right? So if you go 1 this direction, you're up to 1. If you go 1 this direction, you're up minus 1. So all that being said, we're going to go minus 6. So we're starting down here, let's say. Then we're going plus 7. Now plus 7 means in this direction that's plus, and this direction would be minus. But for this purpose, we're going to plus 7. So we go the 6 to here, and then 1 over to 7. So that jump is plus 7. We started at minus 6. Then if we minus 8, well, we jump back 1 to 0. And then we go 7 more, so that's to here, at minus 8. Or sorry, that's minus 7 there. This was minus 6. And then plus 9 is going to jump all the way back, plus 2, because that's 7. Then there's 2 more to 9, so this gets us to plus 2. So this is a nice visual way to think about it. Another potential way to think about it is to chunk and to say, okay, if I put those things together, well, that gets me plus 1. And if I put those things together, well, negative 8 plus 9, well, that's plus 1. So what do I have? I have 1 plus, 2 plus, plus 2 is the answer to this question. Number line, chunking, however you want to work this out, make sure you're going in the right directions and you're starting in the right places if there's minus signs or plus signs. Don't forget, negative numbers are a thing. So that is question 1. Question 2. There's always going to be an A part and a B part to this moving forward, because we want to make sure that you know when you take any sort of number, we're going to use 3.14 times 1,000, let's say. When you take any of these numbers and you divide or multiply by some number that's like 10 or 100 or 1,000 or a million, one with a bunch of zeros, we essentially get these number of zeros is the number of places the decimal point moves. When you times by 100, you're moving it that way. So the decimal point moves once, twice, and 3 times. Don't forget there's a phantom 0 there. So we move that 3 times because 1,000 has 3 zeros. So the answer would be 3140. 3,140 is 3.14 times 1,000. Now divide. With divide, we actually have to move that way, the decimal point. And so it goes 1, 2, 3, over. Don't forget there are phantom zeros. So the answer here is 0.00314, because I moved that over once, twice, 3 times. So 1,000, if it was 10, you just move it once. If it was 100, you move it twice. If it's 1,000, you move it 3 times, etc., etc. So I could give you a billion, and you'd be able to figure this out by moving the decimal point. So that is the answer to question 2, and I hope that's obvious there. Question 3. Question 3 is 1 kilometer into centimeters. I'm giving you these because now they're farther apart. So it's no longer kilometers to meters, but we could do that. We could say 1 kilometer equals how many meters? Okay, well, there's 1,000 meters in a kilometer. We just know that. That's a fact. A meter is about 1 step. A kilometer is about 3 laps around a track. So we end up getting 1 kilometer is 1,000 meters. But now, so since those are equivalent, we could say, what's 1,000 meters in centimeters? Well, and I know that 1 meter is 100 centimeters. So what do I do with this fact? Well, do you see how I can scale this up? So this scales up by 1,000. Now, if I scale that up by 1,000, since this is equivalent, I can just scale this up by 1,000. So scaling up by 1,000 here is scaling up by 1,000 here, and we know we can just move that decimal point. So 1,000 meters equals 100 times that, so 100, moving the decimal point, so we moved it once there, we moved it twice there, we moved it 3 times there, there's 3 zeros, move it 3 times, put a little comma, I got 100,000. So 1 kilometer equals 100,000 centimeters is the answer there. So that is our answer. 100,000 centimeters equals a kilometer. Again, a centimeter is about the width of your thumb when you put it down. So you know 100,000 thumbs is a kilometer. Question 4. We've been doing lots of percentages, and I just want to review a few. So let's take a nice number like, let's do 500. 500, well, we know 50%. I can do 50% by just doing half, right? So 50% of 500 is 250. I could just divide 500 into 2. So you know if something is half off, it's only costs 250 bucks now if it started at 5. But you can also do 25%, because 25% is just half of half. So if I already got half here, I can half that again, and 125 is 25% of 500. So I just halved, and then I halved again, and I got 25%. But what if I wanted 10%? What do I do for that? What's the trick? Well, we've been working for the last couple weeks on taking 500 and then moving the decimal point once. So 50 is 10% of this because this phantom decimal point moved 1 over. So 50 is 10% of 500. You just have to move the decimal point, make it smaller. That's 10%. Now, in questions moving forward, I can take this, and then I can ask you from this, what's 20%? Well, 20% of 50, 20% of 500 is just double this. It's double 10%. So it's 100. So 20% of this whole thing, I used 10 and then I doubled it. Now, you can start to see this pattern emerging where I can half and use some tricks to figure out a whole bunch of different percentages. I could also take and do 5%, which is what the question today is. So 5% of 500 is going to be half of 10%, because 10% and 5%, that's just half of that. So 5% equals 25. So 5% equals 25 is the answer to 5% of 500. Let's actually do today's question, which is 5% of 140. So I'm going to take 10% and say it's 14. That's my first jump. And then my next jump is taking half of 14, which is 7. So for today's question, I went from 140 to 14 to 7, and we know that's 5% is 7 there. So that's question 4. Question 5. Now we've been talking a lot about area, perimeter, and now we're going to talk about volume. If perimeter is what it means for me to walk around the outside of something, it comes up with a length. Let's say it's in meters. If I then walk over the whole area and I zigzag back and forth and I do this, that zigzagging is now area. So this is perimeter. And it's going to be in meters. Area is going to be in meters, but this interesting unit called meters squared. That's because there's like a square footage. There's an amount that you're touching over the entire surface area of something. And volume would be like if I wanted to put a layer of topsoil over this whole area that was like, let's say, 6 inches high, then volume would be amount of space. It's the amount that things take up. It's like the cup of water that you're holding. Or it's like a basketball and how much space a basketball versus a baseball takes up. A baseball takes up less space. A basketball takes up more. It's got a higher volume. So the volume is in meters cubed to the third. Now again, just letting you know this, that if I gave you a unit in meters squared, you'd know I'm talking about area. And if I gave you something in meters cubed, you'd know I'd be talking about volume. So normally in volume, the easiest thing to do is a box. And we just draw a box like that. That's 3-dimensional. I'm not a very good artist. In this case today, we have all of the sides being equivalent. 3 meters, 3 meters, 3 meters. Volume is base times length times height. So again, that is this side is the base, this side is the length, and this side is the height, how far it goes up. Base times length times height is the volume. So if we actually plug this in, 3 times 3 times 3, that's 9, times 3 is 27. 27, what are the units? Well, it's meters cubed. Don't forget about this cube. Units are important because if you're trying to convert between things and you mess those up, someone might be talking about imperial systems or whatever, and if you're on a construction site and you're talking about how big do the hot water tanks need to be, and if you mess up these units, then you can really get some wild projections or spend way too much money. So this is question 5. Again, base times length times height will get volume. And if you're looking for a bonus question, you could always search or figure out the surface area of this whole cube or the perimeter to walk all the edges of this cube. Those are always fun questions to try to figure out, but I will leave you to figure that out by yourself if you're interested. That's how to do this question. Alrighty, let's do question 6. So we have been talking fractions for a while, we've got an example here of 7 over 10 minus 2 over 5. What does that equal? And we always pair it with the next question, which is looking at multiplication or division. In this case, it's going to be division. 2 over 5. These are different, and division and multiplication are actually easier over time. So I want to start with division. Multiplication and division. If this was multiplication, you would just go straight across. But because of this division, there's actually a really simple trick. And it sounds kind of ridiculous, but it just works. Whenever you see division, the only thing you have to do is you change division to multiplication and you flip the bottom and the top numbers there. So this comes up, this goes down, and we actually have 5 over 2. So if I were going to rewrite this, I'd say 7 over 10 times 5 over 2. That original question, divide 2 over 5, is actually the same as timesing by 5 over 2. Those are the same thing. And I know that sounds weird, but this division, again, you just turn into a multiplication and you flip the fraction. You put the top on the bottom and the bottom on the top, and then you just multiply like you would have anyways, straight across. 7 times 5 is 35. 10 times 2 is 20. 35 over 20 is the answer to this one. Division is almost exactly the same as multiplication, but you just flip it. So let's go back up here. Addition and subtraction of fractions is one of the harder things that you have to do. And it's because these denominators need to be the same. So we can't deal with denominators that aren't the same. This can't work. You can't do this question like this. You need to get this number to be the same as that number. So how do we do that? Well, fractions do this interesting thing where if you scale it up, if you times the top and the bottom by the same number, it actually gives you the same ratio. We can see that 5 goes into 10. So I can make this 10 if I multiply by 2. And if I multiply the bottom by 2, I have to do that to the top. And so that's going to be 4. So really, 7 over 10 minus 4 over 10 is the same actual response here. It's the same question. All I did was convert this fraction to make it the same denominator. And so same thing as addition. Addition and subtraction are the same. You just do the tops and the bottom stay the same. So that's going to be all over 10. 7 minus 4 is 3. The answer to this question is 3 over 10. So hopefully you can remember that the bottoms need to be the same. You scale that up. You need to do the same thing to the top. You're just replacing this side of the fraction. And then you just subtract the tops. And that's all you get there. So multiplication and division of fractions, way easier. Addition and subtraction, way harder because there's more steps. And I haven't even given you hard numbers for that. We might not even get there, but if you want to give yourself a challenge, try to make this number a 3. Figure that one out. All right, question 8. Question 8, here we go. So we're just doing more of these powers because getting used to exponents is probably one of the most important things we're going to do. We're going to try to get to a point where we're doing this theoretically, meaning if I did, let's say, x squared minus y squared minus x squared. How would you end up doing this? This kind of stuff, don't worry about for now, but that's like where we're going, because you need to be able to do this stuff theoretically, not just practically with numbers. 4 squared, 3 squared, 2 squared. This is just how many times you multiply it by itself. 4 times 4 minus 3 times 3 minus 2 times 2. Each of these chunks, we got 16 minus 9 minus 4. When you subtract those through, 16 minus 9 is 7, minus 4 is 3. The answer here is 3. To that question, don't forget it's not 4 times 2, it's 4 times 4. That's question 8. Now question 9 and 10, I know folks are having a lot of difficulty with. So we're going to go over question 9 and algebra. If you want to search this out, search out the word algebra and look it up if you're still having difficulty after doing this. It's so foundational. It is math grammar. It is how things move around. Grammar. The question I gave you now is 4x minus 8 equals 0. So what's the purpose? What are we trying to do here? We're trying to get x alone. And in this particular question, you move or you undo the 8. Actually, I'll switch colors here. You undo the 8 by adding 8. But there's this equal sign, and if I add 8 to this side, then I've thrown off the balance of the equation. So then I need to add 8 to both sides. That actually cancels this one, and I'm left with 4x equals 8. So now I could gut check this and know that's 2, but let's actually do the math here. So the math would tell me that I need to get rid of this 4, and so I divide 4. But if I did something to this side, I need to do it to this side. I divide 4 there. 8 divided 4, x equals 2. So that's my answer off this question. And I just want to give one more exemplar here. So I can have multiple steps in algebra. So I can have a question, let's say, like x minus 3 divide 2 equals 5. So how the heck do I do this kind of question? There's like a division, the x is on the wrong side. Well, it actually doesn't matter. The x can be on either side. So we could really rearrange it if you wanted to. So we could rewrite this x minus 3 over 2 equals 5. Those are the same. I just flipped the same, right? It's just like looking at it frontwards and then looking at it backwards. Same thing. So if that makes it more comfortable, what do we do first? Well, in this case, we can't actually divide the 3 because it's stuck under this divide by 2. Or we can't subtract the 3 or add a 3. We need to address this 2. So if we multiply by 2, that will get rid of that bottom. That means we need to multiply this side by 2. So now I'm left with x minus 3 equals 5 times 2, which is 10. So this might look familiar. We got x minus 3 equals 10. I'm going to add 3. I got to add 3. X equals, those cancel, 13. So there's a few different principles in there. One is that you can flip things whenever you want over the equal sign as long as they're exactly the same. And the other piece is here that in this kind of question you have to start with the bottom, get rid of that, and then do the addition. There are lots of practice questions online for this. Khan Academy is great for this. Just search algebra and just start working through stuff. These are such fundamental skills that need to happen, and hopefully this helps. And last but not least, we're going to go over some Question 10, graphing. In this, I give you y equals negative 2x plus 3. There's a few things that I need folks to know. One is that when you graph this, we're going to put the graph over here. There are two pieces to all of the formulas or all of the equations that you're going to get. One is this chunk after the x, and the second is the chunk with the x. This talks about slope. That's the word that we use for it. This stuff talks about position. Or we can also talk about the y-intercept. Y-intercept is a fancy word for where this equation hits the y-axis. Don't forget, this is y, this is x. So if I actually just thought about this for a second, I can disregard this and I know this hits plus 3 up on here. So I can literally just draw a point. If that is 0 and 3, that's plus 3. I know whatever I draw is going to go through there. So then slope. Slope has to do with how steep a line is. So if it goes up or down or points up or down. In this case, there's a negative. So I know that this is actually going to look like this. But how did we get there? If you haven't graphed this a lot, this is the kind of line that I would draw. We make a t-chart. We say, and I'm actually going to erase this for now, but we know where we're going. X and Y. So why do we do this? This is literally the only way that you can list out, knowing the math that you know, different combinations of these pairs that will then give us an x and a y value. And we can place this all over this coordinate system. So we can say if x equals 0, I'm plugging in 0 here. I've got 0 times negative 2, which is 0. Then I've got a plus 3. So 0 times negative 2 is 0 plus 3. Well, that's actually 3. So when x is 0, right in the middle here, y is plus 3. Cool. So we got that point plus 3 up there. Let's try x equals 1. So 1 times negative 2. Well, that's negative 2. 1 times negative 2 is negative 2. Plus 3. Well, negative 2 plus 3 actually gets us to 1. Okay. So we're in the positive 1 there. So if I have 2, 2 times negative 2 is negative 4, plus 3 is negative 1. Now, you might be seeing a pattern there. Really, this is minusing 2 each time, each step. So we could just say 3 and minus 3, and 4 and minus 5. That's the stepwise how things are going. So if I got here, then I got 1 and 1. Then I got plus 2 and negative 1, which is like here. And so again, that looks an awful lot like the line that I was drawing. The t-chart is essential. And every time you're given one of these, make a t-chart and plot these values. And again, I get these values. So if I had like negative 5 and 4, let's say, this is how I would show a point, right? This is the x, this is the y. Where is this point on here, just quickly? Well, if negative 5 is x, that's like somewhere out here, but also 4 up in the y, that's about here. So this point is right about there. Now what if I had negative 5 and minus 4? Well, negative 5 is over there again, and minus 4 is about the mirror point of that. So we got a plus 4 and a minus 4 in those points. Those are two other random points that I'm putting on there just to demonstrate again the coordinate system if you've forgotten where things are. hopefully this helps. The whole concept is t-chart, plug in the values, find what it equals, and then put those points on the graph. And you need at least 3 points overall. But I always like to do a fourth in case I've kind of screwed up somewhere and the math went wonky. So let's say one of these points also got calculated and you were like out here and you had these other 3. Well, unless your graph's going to do this, which it doesn't, and you don't know how to do yet, then this point is wrong and you might want to check your math. So that's a good way to double check things. So hopefully that's helpful. If you have any questions, good luck with 10 question quizzes, and let's tackle the second part of the year here.